everybody, it's Mrs. Gano. This time I'm doing chemistry in my classroom, not in my kitchen, because the magic pitcher doesn't travel well. So I have a magic pitcher demo I wanted to do for you guys. This one comes along with a story that when I was in college, I was studying chemistry and chemical engineering, and I had a job at a place called Cheez-Its. And they served all kinds of cheesy things. They had cheese pizza and cheese fries and cheeseburgers and cheese nachos and stuff, and only two things to drink, water and juice. Now, I, as you might imagine, was a pretty terrible waitress because I can't remember anything from 1 second to the next, and I don't really like being around people very much. And so it made it difficult because when I would go to a table to serve some people, I wanted to get out of there as quickly as possible. I wanted to give them their drinks and take their order all at the same time. But because I couldn't remember everything, I needed one hand for my notepad and I needed two hands for the drinks until I developed the magic pitcher, which could serve either water or juice, depending on what I told it to do. So one time I had a table with 4 people at it, 4 guys. I came up and I said, "Hey, welcome to Cheez-Its. I'm your waitress, I'm gonna take your order." And the first guy, and I said, "What would you like to drink?" And the first guy said, "I'll have some water." And I said, "No problem. I will pour you a glass of water from the magic pitcher." And the second guy said, "But I don't want water. I want juice." And I said, "That is not a problem. The magic pitcher will serve you whatever you want." And it served him a glass of juice. And so the first guy said, "Whoa, that juice looks pretty good. I think I want some juice." And I said, "All right then. I will take your drinks back. I'll serve you guys both some juice." And the third guy said, "But I don't want juice, I want water." And I said, "That is not a problem. The magic pitcher will take care of you." And so I poured him a glass of water. And then the first 2 guys are like, yeah, we want water instead. We changed our minds. We don't want juice, we want water." And I said, "All right, fine. I will take your drinks back. And I will serve you guys all a nice glass of water." There we go. And the fourth guy said, "But I don't want water, I want juice." And I said, "That is not a problem because the magic pitcher will serve whatever you want." Gave him a nice glass of juice. And then the first 3 guys were like, "Oh, yes, we changed our minds again. We decided we want juice." And I said, "Fine, I will take back your drinks. And I will serve everyone juice." And then I walked away from that table as fast as I could. So that is the story of the magic pitcher. Now at this point, you guys would all applaud and I would take a little bow. And then I would explain to you what's going on in the magic pitcher. Now some people think that there's something inside the pitcher, but there's not. It's just a target pitcher. It has nothing in it. Right now it's full of juice, purple. And the reason that this is working is because in the pitcher, instead of just water, I had water and an acid-base indicator called phenolphthalein. Phenolphthalein changes color when it's in acid or if it's in base. Actually in acid, it's colorless, but in base, it is pink. And this is a very, very dark pink, so I added quite a bit of phenolphthalein in here. So phenolphthalein is a really nice indicator, spelled funny, phenolphthalein. We use it a lot for acid-base titrations. So let me just show you. I've got here some 6 molar sodium hydroxide. That is a base. It's a strong base. And I've got some 6 molar hydrochloric acid. That's an acid. It's strong acid. When I say strong, I don't mean dangerous necessarily. I mean dissociates completely. And so just to show you, if I add acid, it will change color. It will go back to colorless because now there are more hydrogen ions in here than hydroxide ions, and the phenolphthalein reacts to that. And so what was happening as I was mixing my things, there you go, is my phenolphthalein was changing color. So in my pitcher originally, I had just colorless water with phenolphthalein, and in this first beaker, I didn't have anything. I poured out a glass of water. But in this beaker, I actually had a few drops of base at the bottom. And so when I poured the water, and if you want to go back and look at the video, you might be able to see, I pour it clear, but it turns pink in the beaker. And then when I took these two beakers back and put them in here, it turned my whole pitcher pink. And so then I could pour out 2 pink beakers. In the third beaker, I actually had 12 drops of acid. And so even though I was pouring it in pink, it turned colorless in the beaker. And then when I took these first 3 back and put them in here, it was enough acid in here to make my whole pitcher go colorless. So I could pour 3 glasses of water. And then in the fourth one, I had about 15 to 18 drops of base. That was enough to turn that one pink, and enough that when I poured all of these back in, my whole pitcher turned pink. And so you can see even now, it's pouring pink, but staying colorless until the amount of base overwhelms the amount of acid, and then it will stay faintly pink. And it's actually quite a bit of acid that I've got in there, so it's still turning colorless. So this is an amazing ability of indicators to help us determine when we have an acidic or a basic solution, and we use these for titrations, which you will see some videos about. So thanks for joining me and doing chemistry with me, and I will talk to you guys later. Bye.